to remember. What are the two words on what to look for when attempting story problems? What keywords do you want to look for? Totals. And what else? Units. If you can figure that out, you can get all of your story problems completely. And it's very simple. So the first few problems we go through, you're going to have kind of this template of what to go through. The goal is on the test, and even a couple of homework problems, there is nothing. It's just a paragraph with a grid for you to graph on. So we have to figure out how to be given a paragraph and do all of these steps. But once we get to this step, once we get to write a system of inequalities for us, it's no different than part one. You graph the system, you find the vertices, you plug it in, function, max and min. The only thing that we're figuring out today is how do we create the system from a story problem. So let's start. You need to buy some filing cabinets. So you do your research. You know that cabinet X costs $10 per unit. It requires 6 square feet of floor space and holds 8 cubic feet of files. Cabinet Y costs $20 per unit, requires 8 square feet of floor space, and holds 12 cubic feet of files. You have been given $140 for this purchase, though you do not need to spend that much. And the office has room for no more than 72 square feet of cabinets. How many of which model should you buy in order to maximize the storage volume? So that's really what's going to be on your test. Just that paragraph, nothing else. And we have to figure out how to create this system. The first thing you want to do is define your variables. So we can be creative. What do you want your first variable to be? X. Good. Very creative. X. But we need to find it. What is X going to represent here? $10 per unit. So let's just make a list. We'll figure out what people think. X represents $10 per unit. Anybody else with an idea? Anything else?
6 square feet.
You think X means 6 square feet? You said $10 per unit. What does X represent?
Cabinet X.
Cabinet X? Anybody else have an idea of what X may represent? So if you can't define your variables, can you write a system of inequalities? That's why it's the most important part. Now, the closest one is cabinet X. But it's not just cabinet X in the way that we see it. It's cabinet X, but something with it. So we need to figure out, how do we interpret our paragraph? Our paragraph gives us every piece of information we need. Everything we need is given in the paragraph. You don't have to create something out of nothing at all.
10x.
What? It's not 10x. It's something with cabinet X. You'll see people who are saying 10x and stuff like that, you're going to see that pop up. But the part of the paragraph that tells you how to define the variables is the last sentence. It's the actual question. How many of which model should you buy? Is not what you're solving for. You solve an equation, you solve for X, you solve for Y. We want to know how many of which model should we buy. So when I define the variables, the number of cabinet X's. So we want to be creative again. What's the next variable going to be? Y. The number of cabinet Y's. So we don't have to pick it out of nowhere. We don't have to. It just tells us. What are you trying to find? We're trying to find how many cabinet X's and how many cabinet Y's we should buy. So those are our variables. So the problem even tells us how to define our variables. You could have been more creative. Last year we had a class that made X the number of cabinet Y's and Y the number of cabinet X's. That was a lot of fun. Oh, because it was fun. So now we know that. And here's the good news. once you use something, it's gone. We don't have to figure out anymore anything with just that first part I underlined. How many of which models should you buy? We used that already to define our variables, so it's gone from our paragraph. So now we need to highlight similar units. So we go to the paragraph. What similar units do we have? Money. Good. Cabinet X costs $10 per unit. Where else do I see dollars? Cabinet Y costs $20 per unit. What's important about that $140? You've been given $140, but there's something else with that. It's the total, but you do not have to spend that much, correct? So you have the units and you have a total, so you have an inequality, don't you? So what should I write that inequality as? Well, less than or equal to what? Less than or equal to 140. Well, I need the other side. If I say x plus y, what's this unit right here? Money. So I need what on the left side? I need 10x plus 20y. I need money on the left side to equal money on the right side, don't I? You need to match the money on the left, the units on the left, to units on the right. So I get 10x plus 20y is less than or equal to 140. $10 for every cabinet X you buy, $20 for every cabinet Y you buy. I mean, it should make sense. You multiply how many you buy by how much each one costs, it gives you the total. And we graph it. To graph, here's what we're going to do. Because sometimes your grid is not going to be equal, it is. You could do slope-intercept form, but sometimes it's just nasty to apply slope. So what we're going to do is we are going to do x-intercepts and y-intercepts. We're going to kind of use the idea of standard form, and we're going to use a straight edge. X-intercept is set the x term equal to the total here. So 10x equals 140, x equals 14. So I go to my x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You plot a point on 14 on the x-axis. The y-intercept is take the y term, set equal to the total of 140, so y is 7. So 1, 2, 3, 4, 5, 6, 7. I plot the y-intercept. I have 2 points on that line. So I just connect those 2 points with my straight edge, with my ruler. Draw the line. You want a straight edge because you're not using slope. If you don't use a straight edge, does anybody know how to draw the straightest line without using a straight edge? No, that's a still straight edge. It's not a ruler. Anybody ever see anybody mow long fields? You ever notice how those are like perfectly straight? Anybody know how they do that? No one knows? They keep their eye on somewhere straight in the distance the whole time at the complete end of the row, and they just keep their eye focused on that, and they don't worry. But when you're pushing your lawnmower, you're probably looking down, trying to make sure you're in the same grooves, and you start to swerve a little bit. But if you look straight ahead and you just keep your focus on that, you go straight. And so it's the same thing with drawing a line here. Is I know my slope would be, what, -1/2 here if I were to do it? And so I just keep my mind, because I don't have a straight edge. I just look every -1/2 and I draw. What can I have to replace? So I go like this. So I'm not using a straight edge. I'm living dangerous. Oh, that was curved at the end. Not bad for a straight line. Last stand, where would I shade? Down. So you guys can do this with a pencil. I would lightly, because you have it highlighted, don't like cross out completely, but lightly cross out what we used. Because once you use it, it's gone. Now I'm going to make my life a little bit easier. I'm going to go through and I'm going to just erase everything that we used so far. Then I don't have to go through the weeds and see what else is left over. All right, so we use dollars. We have our total for dollars. We're good. What other units? Well, I'm erasing. What other units?
72 square.
Square feet. So square feet is another unit that we need. So I'm going to highlight 6 square feet. That was for cabinet X, correct? Where else do I see square feet? 8 square feet. That's for cabinet Y. Where else do I see it? And what's important about that 72? It's a total, and it says no more than 72 square feet. So I have my units, I have my total. So it's going to have to be square feet equals square feet. So I have to have square feet. So what would I make my inequality for this one? 6x plus 8y is less than or equal to 72. And it should make sense. Every model X takes up 6 square feet. Every model Y takes up 8. So if I buy 2 model X's, that's 12 square feet it's taken up, right? So it should make sense why this works. And we have our total less than or equal. So we'll do X-intercepts again. 72, set 6x equal to 72. X equals 12. So if this was 14, this was 12. 8y equals 72. Y is 9. So if this was 7, then 2 up is 9. You have 2 points. Connect them with a straight line. So same idea, -3/4. So it's going to be a little bit harder. And, it's going to be harder too if that happens. Almost messed up my line. And I go down. Oh, that's just beautiful. Because I noticed what happened right there. What do I see happening with the green and the blue lines? Intersect somewhere nice. So I did a good job in the straight lines. So we see something right there. That's a really good point. It could be a vertex, couldn't it, that we're going to use? So that should stick out in your mind. So we use square feet. I would take your pencil and lightly cross out so you can kind of still see what you used. I'm going to take my eraser and I'm going to get rid of it. And all right, what other? Cubic feet. That's another unit I have, correct? All right, so let's highlight cubic feet. We have, 8 cubic feet for cabinet X. And 12 cubic feet for cabinet Y. So I have cubic feet. So what's my total have to be? Oh, good, you're matching the units. So what's the total? What? We don't have one. There is no total. Why is there no total for cubic feet? Well, why isn't it given? What was that? Is that the max? Good job. Maximum storage volume, correct? Do we have a total? No. If you don't have a total, and this is something to write down, is if you go through and you match units and you see you have a unit with no total, that creates your objective function. And the problem tells us we want to maximize the storage volume. Isn't cubic feet volume? So we don't know what the maximum volume is. We're trying to find that, aren't we? So the question itself at the end, how many of each one do we have to purchase in order to maximize the storage volume, that tells us our variables, and it tells us what we're trying to find unit-wise for our objective function. So what is my objective function going to be written as? F of x comma y. What was the cubic feet for x? So 8x. What was the cubic feet for y? 12y. There's your objective function. Because there is no total, because the question says you want to find it. All right, let's see if there's anything else. So I said you can lightly cross out. I'm going to erase. And let's read the prompt to make sure there's no other totals that we're missing. So the problem says, now you need to buy some filing cabinets. You know that requires of floor space and holds of files requires of floor space and holds of files. You have been for this purchase, though the office has room for of cabinets in order to. Do we have any more units or totals? No. So we're done. Kind of. You're missing 2. What do you mean X and Y? Say it louder. You can't purchase negative filing cabinets. We kind of went over that with the ticket problems yesterday. But last time we had the lesson is if I go under, because both of these are less than, so I'm shading down. But if I shade down, I'm saying here I'm buying negative Y filing cabinets. I'm saying here I'm buying negative X filing cabinets. It doesn't work. So then I need a vertical line here to say I can buy 0 or more than 0. I can buy 0 cabinet Ys or more than 0. So my shaded region is this quadrilateral. As soon as we got the system of inequalities, we were able to graph just like we did in the previous problem. Then I got my vertices here, 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 and here. 4 vertices. 0, 0. And then what's the other one? 0, what? The top one? 0, 7. 1, 2, 3, 4, 5, 6, 7, 8, 3. 12, 0. There's your vertices. And that's no different than what we did with just linear programming, not the story problems, just inequalities. Now we're going to take those vertices and we're going to plug them in to our function. So we have our vertices, we have our function, bless you, and we have our, really, the problem says we want to maximize, doesn't it? So I'm trying to find max. 0, 0, that's the vertex. If I buy no cabinet X's and no cabinet Y's, how much storage volume am I going to get from my cabinets? None. If I buy 0 cabinet X's and 7 cabinet Y's, I'm going to have an 84 cubic feet storage. So you may just be writing down the numbers, but realize what that's telling you. It's telling you how many X's you're purchasing, how many Y's you're purchasing, and calculating the volume of each one, and then adding it. 8, 3? 8 times 8 plus 12 times 3. I think that's 64 and 36, right? 100, right? Trust me, it's 100. Pythagorean triple. 12 and 0. 8 times 12 plus 12 times 0 is 96. So which of those is your max? 100. So we need to figure this out. Last time, we just deal with linear programming, not story problems. We would say you have a max of 100 at the coordinate 8, 3. But the problem is we have a story problem. So we need to put our answer in context. What does 100 represent? What's the units? Cubic feet. So I write down feet cubed for cubic feet. Now, how do you get that maximum storage? How many cabinet X's do you buy? 8. How many cabinet Y's do you buy? And there's your context for your answer. You're just putting the units back. Instead of leaving it as a coordinate, you're telling me that 8 represents the number of cabinet X's you buy, 3 represents the number of cabinet Ys. The 100 is cubic feet. So I went through a little bit. Do we kind of see how totals of units helps you create everything? Story problems are not hard if you get that down. In this problem, because it said in order to maximize the storage, I erased it. I can put it back up, but the problem originally said like how to maximize the storage for you. We just have to do the max. To know which one to do, you read the problem, the question, figure it out. So we'll read it this way and determine it right away. A landscaping company has crews who mow lawns and prune shrubbery. The company schedules 1 hour mowing jobs, 3 hours for pruning jobs. Each crew is scheduled for no more than 2 pruning jobs per day. Each crew's schedule is set up for a maximum of 9 hours per day. On the average, the charge for mowing a lawn is $40. The charge for pruning is $120. Find a combination of mowing and pruning that will maximize the income the company receives per day for one of its crews. You will only be given a paragraph and a grid, and you have to generate the whole thing. Right now, the prompts are there to help you see the process. First thing, define the variables. Where do you look in the prompt to find how to define your variables? Where do you look? It's always the same place. Last sentence. Find a combination of mowing and pruning. And then it says that will maximize the income. So what do you think X is going to represent? What about mowing? Money. Money made, it deals with the maximum, right? It's the number of mowing jobs. What do you think Y represents? Number of pruning jobs. You want to figure out a combination of mowing and pruning jobs. How many mowing jobs am I going to have? How many pruning jobs am I going to have? Could be 3, could be 2, could be 7, could be 5. So it's got to be the number. So that takes care of that. And Logan, your question being the idea of how do we know max versus min? It says maximize the income, right? So that tells us right away when we're dealing with our function, we want max. We don't need to worry about the min. So I'm done with that last sentence, aren't I? But I'm going to keep the idea that what's the unit for maximum? Money, income, isn't it? That's going to help me with my objective function. So I'm going to keep that there for me just to make it a little bit easier to figure out what my objective function is. All right, what units do we have? Hours. I see 1 hour for mowing and 3 hours for pruning, and you said 9 hours. So that's the total, but let's look to see, is there something important about that 9 hours per day? A maximum of 9 hours per day. So hours, total of hours. Looks like I have everything I need for my inequality. So what would that inequality be? 1x plus is less than or equal to 9. 1 hour for every mowing job, 3 hours for every pruning jobs. Can't have more than 9 hours. That makes sense. So X-intercept to Y-intercept, just like before. X-intercept. Set the X term equal to the total. So in this case, X equals 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Y-intercept. Set the Y term, which is 3y equal to 9. Y equals 3. So I got my 2 points. I connect them with a straight line. I would use a ruler or be very good at drawing straight lines. And I'm going to go in the negatives. There we go. Less than, correct? If it says less than, I would shade under. All right, so I used them. I'm going to ignore them from this point on. They are gone. Boom, boom. What other units do I have?
Money. Third.
Money, let's look at that. Charge $40 for mowing the lawn. Charge $120 for pruning the lawn. So I have dollars for mowing, dollars for pruning, so I need my total. What's my total? We don't have it, do we? So what does it represent? It represents the function. If there's no total, f of x comma y equals, what is it, 40x plus 120y. So if you're going through and you're looking at units and you go, there is not a total for this one, there's a very good chance it's your objective function. To verify it is, look at the units in the last sentence. Maximum income, that's dollars. So that tells us we have it. So I can cross this out. I'm done with those units, not going to use them again. What else do I have? No more than 2 pruning jobs per day. So what would that be? No more than 2 pruning jobs. So if I have the company and I say I want to put out for pruning jobs less than or equal to 2, right? And that's, what is it, our y variable? How many jobs can they do if I say no more than 2 jobs? 2. What else could they do? 1. What else could they do? What else could they do? They can't what? They can't do negative jobs. So right now I'm saying, hey, less than 2. But I have to do what? I have to stop it at what number? 0. So 0 is less than or equal to y, which is less than or equal to 2. Compound inequality. Makes sense? So then that's a horizontal line at 0. We're going to stop it from going in the negatives. Horizontal line at 2. And our solution space is between those lines, correct? That's good so far. We're missing something though. You can't have negative pruning jobs. Can you have negative mowing jobs? So I need x is greater than or equal to 0. That's going to stop the solution space from going into the negatives. And there is our solution space. And I see the vertices. I have 0, 0, 0, 2, 3, 2, and it looks like what, 9, 0? Not bad. We already have our objective function, correct? So we told you units and totals are the key. We can see how they line up. That's why I said hopefully you can kind of color code, you can highlight whatever to make it easy for you in the beginning. What is the other part though? There is something else. It's not just units and totals. How have we gotten the other 2 inequalities? They've always been greater than or equal to 0, haven't they? Now that's not always going to be the number, but you can never really take something into the negatives in the real world if you're selling or building or doing something. So you need to make sure you keep in mind that there will be some hidden that you have to create. So I have my table. Remember, the units here for the max is dollars. I have my vertices, and I have my function. And I'm just going to plug them in. 0, 0 means the company does not mow or prune any jobs. How much money are they going to make? Nothing. I mean, I could plug in 0, 0, but context tells me what I'm trying to find. 0, 2, they don't mow any, but they prune 2 jobs. So 40 times 0, 120 times 2, they should make $240, shouldn't they? I have 3, 2. They mow 3 jobs. They prune 2 jobs. They should make $360. What if they mow 9 and don't prune any? They make $360. So we have a max of 360 at what? 90 and 32. So we need context for that. They'll make a max of, what's the units for 360? Money, so dollars. What does 9 represent? 9 mowing and 0 pruning jobs. Or what could they do? 3 mowing and 2 pruning. And there we are. When you state it, you gotta put it back in context. Now, what does this mean? This is the really cool thing that we need to kind of realize. Linear programming, it goes beyond just the idea of maximum income, maximum profit, stuff like that. Even computers, when you deal with network flow, you think about it, they want to maximize the amount of computers that can access a network without slowing things down. And so that's a linear programming model. It's not the same thing as a graph. It's a different type of graph that we use. But if I was the landscaping company, now look, these 2 points gave me my maximum, correct? Does that mean I'm always going to be at those 2 points? Where would I want to be as the company on the graph to maximize overall, to make sure I'm making the most profit? I'd want to be somewhere around here, wouldn't I? I'm not always going to be here, but I'm here. If I start to see I'm coming down this way, it should make sense. You have less mowing, less pruning jobs, you're going to make less money. I want to stay somewhere really in between these in this shaded region to maximize my profit. If I start to see it slip, I'm doing something wrong. So, on the homework, what I want you guys to do for it is I want you to